Okay, so yesterday, is that working? Yesterday, we started inheritance. And this because it was like just have the lecture. I said maybe it's better to revisit the concept again, and then we go through it step by step, build on top of that. So something that I'd like you to do today is to open your laptops, make sure your compiler is ready, because we are going to write things while we are going in inheritance, right? So be ready with me, because we don't want to waste time, and we want to be practical as well. So the first thing that we would start with, I'm assuming you already have the point class, right? Because we implemented this before, and you have it in slides anyway, right? The only difference that you need to make in this class is change X and Y to be protected. Previously, they were private. And also add this function or method, right? Called public string to string. And once you do this, I'll give you a couple of minutes for that. And then we move from there step by step. Okay? So you have 2 minutes to write this class or modify it if you already have it. Why are you looking to me? Start doing that. Again, if you have issues with your laptop compiler, you can use tutorials point online Java compiler. It works perfectly. Oh, yes, set point should be this one. I guess previously we had set X, set Y, right? So you have to write down this class into your own either laptop compiler or an online compiler, because we are going to go through an example of inheritance one by one. Right? So write down. I assume you already had this from previous lectures. Then modify it only to have X and Y as protected, and add this function. And another change is previously we had it set X, set Y. Now we are defining a new method that we call it set point, and we set X and Y together. Right? Make these changes in the class that we had before, or if you don't have the class that we had before, write this down. And by the way, a very important thing that I guess very helpful is, because I told you this in quizzes as well. In quizzes, we are building quizzes on top of each other to have a kind of a mini project, right? Then maybe it's a good idea to have a folder in your laptop that is for lecture quizzes for lecture examples, such that each time I ask you to open a class that we did before, modify it, then you have it already ready, right? By this, you are making yourself kind of ready for the lecture. Okay. One question I have in this method, given that this is the one that we modified right now, what do we do here? What is the purpose of this method? It converts the point into a string representation and then return it, right? This is what we do. But the actual question is, x and y are integers, right? Here. How can I, like, it seems that we are adding an integer to a string, right? How would this be possible? Yeah? Yeah, so something that is powerful in Java and the same thing in C++ is if you want to print something of a value that is not string, like it's an integer or float or double or any other thing, and then you are concatenating this to a string, this is being converted to a string by default. There is, in the compiler, it knows that you want to print the value of x, but x is an integer, and to print something on the screen, it has to be a string. Then it converts it into string, concatenate it, like the plus thing is concatenating two strings together, and then print the whole string to the screen, right? So it makes it very easy to deal with strings, rather than you remember in C, we had to use fprintf and specifiers and these kind of complex things, right? You had to know what thing you want to print or read from the screen. Here it's just like very easy. You have a string, a mix of string, integer, float, double, add them all together, and then print them, they will print, right? Done? Okay, so are you done with this? Guys, you're taking too much time for that. Okay, so while the remaining being done with this example, something that I want to mention maybe for the fourth time. In lab 3, he has also detected similar code, and those will get zeros in the lab, right? Like, you guys should know that if you copy a code from someone or somewhere, there is no excuse for that. You are getting zero, right? So make sure in lab 4 and 5, you do the effort yourself. I told you before, the purpose of the lab is to get your hands on, your hands dirty on writing code. You do your best, you go to utilize the TAs, come to me, make sure you solve your own problem, and then by then you only learn to program, right? Otherwise, if you copy the code from somewhere, what did you do? What is the purpose of the course? Something that may seem like kind of an old advice, but if you keep focusing only on grades, especially for a topic like programming that is very, very vital for your career, if you just focus on grades, you are losing too much opportunity to learn something, right? When you go for a company for an internship or a job, and then they do an interview with you, they don't ask you, did you get an A or A minus, right? Like they ask you to write some code. And then if you are not able to do so, it doesn't matter even if you are getting A, right? So make sure you do the lab yourself. If you need help, go to the TAs, come to me, and we will kind of move through this together. On the other hand, if you copy your code somewhere, go try to do the demo. You are not able to do the demo, you are going to get zero, right? I have no option here. Okay, so let's move on. Yesterday, we already explained what is protected. And then we said we are going to, and here comes the inheritance thing. We said we are going to create a child class out of point, right? In a previous lecture, we created another class that we called circle. And because circle had a point, which is the center, and center was point class, we had to create an object of point inside the circle, which is what we called class composition, right? This was the lecture, I guess, before the midterm. Now, we're going to create the circle class in a different way. We're going to make the circle class a child of point, and by this, we don't need to create an object or do anything. By just creating circle as a child of point, it's going to get all the members of point into circle, including x and y. Good? So how to do this? We had this yesterday as well. And I want you to write this code. What we are doing here is we're creating another class that is called circle that extends the class point. And then it has a constructor that calls super. Maybe after you write this, I'll ask you what does this do. And then we are going to modify circle a little bit to add a new knowledge to you. Right? So please make sure you write this down also in 3 minutes maybe. And then we discuss it together. No, it's different. My circle class that we had before wasn't a child of point. So it's a different implementation. It does the same function, but in a different way. So it's using inheritance to get things out of point. Maybe copy it and then modify it, but keep the old version, for your reference. Okay, so what do we do here? First of all, extends is a reserved word, as we said yesterday, that makes circle a child of a parent class that is called point. Great. And then, what is radius? It's a new member of the child class. We mentioned yesterday that if you are a child class of a parent class, you get all the members of that parent, but also you can add your own. Good? So radius is an example of a member circle can access, but point cannot, right? And yesterday we covered protected, and here we changed X and Y to be protected as well. What is the reason for this? Why we made X and Y protected? Do you remember from yesterday? Yeah? Yeah, private X and Y previously. If you have a member field that is private, that means child classes cannot access this member, right? But you have to change them to be protected. And if you have a member that is protected, that means it's accessible by child classes as well as any class on the same package, right? Remember, we said packages yesterday simply as the folder that you have your project in. Okay? Great. So this is a member of circle, and then this is a constructor of circle. We spent yesterday maybe like 15 minutes discussing what happens when you call a constructor of a child class. So let's revisit this again. Now circle is a child of point. Maybe I create an object of circle, right? And we said once you create an object of a class, the constructor is going to be called. Great. So the constructor of circle is called. The first thing that a compiler is going to do is to call the constructor of the parent, right? So once you call a constructor of a child, before even executing any line of this constructor, the constructor of the parent is going to be executed. Good? So here, we mentioned this explicitly by saying use super reserved word and then pass some value to A and B. What does this line do? What is super A and B? What happens when the compiler incurs such line? Yeah? Yeah? Yeah. So which constructor? Because maybe I have multiple constructors. Actually, here I have two constructors, right? Which one I call? Yeah, the one that has int x and y, right? So super is because also another name of the parent class is called the super class, right? And then the child is a subclass. So once you write the reserved word super, that means please call for me the constructor of the parent. Which constructor? We said we already discussed overloading before. This will depend on how many parameters you pass to the constructor. Here we pass 2. That means we're going to call this constructor. So super A and B is going to call in point int x, y, and then set x and y for the value of A and B, right? Great. And then set radius is going to call the method set radius. Again, similar to radius here, which is a member of only the child class. Set radius is also a method of only the child class, right? So here circle adds another method to the parent class, which means set radius is not accessible by point, but it's accessible by circle. Good? And then get radius is returning the radius. Great. So is there any question here? Yeah. If it's on the same package, which means it's in the same folder in your directory, then you can just write point and it knows that this is the point of the same package. But if you have point, and this is an important question, you can also have a child class to a class that is in a different package, right? But then you have to either import the package at the beginning, as we said yesterday, or write the full name of the point, right? Yesterday we had the example of MacMaster ECE graphic.point, where you just import MacMaster.ECE. Good. Is there any other question? Good. So let's see what happens here. We already discussed this. That's super. So here I want you to write a third class, just the main one. In this one, we're going to test point and circle. So you write your own class, you call it like test class, test circle, whatever. And then you have a main method. In this main, write down this code. Okay? You have 2 minutes for this as well. Everything has to be in the same folder to be able to recognize it. Are you done? What do we do here? So by writing the point class and then the circle class, we are not able to test them, right? You just wrote them, but we cannot run them. Why we cannot run them? Because if you remember from our very first discussion of object-oriented programming, if you create a class, you are creating a data type. But if you don't have an object of this data type, then you didn't do anything. For example, we have the int type, but the int will work only if you define int x, for example. If you create a variable out of this type, assign a value to it, and then maybe print it, do something with it, right? So by just creating the class, we are defining a data type, but we don't allocate any place in memory for that, right? We didn't create an object yet. So what do we do in this test class is we create here an object of the circle class, right? And then we do this using the new server word. And then we call the constructor that has the three inputs, which is x, y, and radius, right? Here, I guess, RAB. We are passing 3.5, 65, and 78 to these. Great. So now we created an object in memory of the circle class. Great. So now we'll try some interesting things. First of all, we say int a equals c.getX, but the circle class has no getX. Why this is okay to work? If you try to run it, it should run, right? Maybe you guys should try this yourself. Why it's okay to run? Yeah, because getX is inherited, it's a method inherited from the point class. And because circle is a child of point, then it also has all the members of the parent class. So it's okay to say c.getX. The same thing for c.getY. For radius, this is its own method. So this is normal, right? Nothing is about inheritance here. Great. Can we also do this thing? You can say c.x, and here is the trick, right? X and y are also, is everything is okay? X and y are members of point, which is the parent class. But these are protected members. They are accessible by the child, right? But here you are writing a code not in the child class, you are writing a code in a third class. So if this class, which let's call it test circle, if test circle is in the same package as circle and point, then this should work, right? But if test circle is in a different package, this will not work. Why it will not work? We said yesterday that a protected member is accessible by the child, and C is a child of point. So why this will not work if this code is in a different package? What do you think? It's the same reason if you say c dot radius, right? We had a variable here that's called radius. If you say c dot radius, radius is a member of the circle, but then this circle is in a different package. That means it does not have access to the radius, right? Because it's a protected member. Again, a protected member is accessible only within the same package. So if this code is in a different package than circle, this will not work, and then c.radius will not work as well. But here this should work because we say, assuming that everything here is in the same package, right? Good? If x and y were private, the same thing for radius, you will not be able to do this no matter what. And we had an example for this before. Great. So now let's add something to the circle class. So we are going to add two methods. One of them is called area, and then we calculate the area of the circle. Just very basic one line of code. Yeah? And then we're going to add another method that is called toString. And then this converts our circle to a string, which has x and y, which is the center, and then the radius, right? Write down these two, and then we will discuss. You have 2 minutes as well. So why it's okay to say math.bi? Why this code is fine without including anything? Yeah? Yeah, the math comes out of that Java like included library by default, and we had an example for this before by using the power function, right? Thank you. Good. Are you guys done? We're only adding a couple lines of code, so you should be faster than this. So for area, it's a very normal method, nothing about inheritance. We are just adding a function that takes no parameters because it calculates the area of the circle using the by from the math library and then radius square, right? By r square, which is the area of a circle. And then it returns double because the area is double in general. This one is the interesting one. Why do you think this one is different than the area one? Why it's interesting? What do you think? Why the toString method here is more interesting than the area one? Yeah. Yeah, because parent class, which is the point class, had previously, just 5-10 minutes ago, I asked you to implement this method in the point class, right? So the point class, which is the parent, has exactly the same method with the same no parameter thing. So it has exactly the same syntax, right? Would this be possible? We said a child class is going to inherit everything from the parent, including the methods. That means now circle class has already a method that is called toString that gets it from the parent, right? Previously, we said a class can have multiple methods of the same name under the condition that it has different number of parameters, which what we called overloading, right? This was okay, but now this is different because this toString and the point toString takes no parameters. So this is not method overloading, right? Why this is allowed? Because in inheritance, if a child implements a method with exactly the same name and number of parameters as the parent, it's okay. And what is going to happen is going to override the original one, right? So as if you're inheriting something from your parent, but then you want to modify it. So if you change the function within your own implementation, that means this is your own toString. So if we call circle.toString, this is the one that's going to be called. So as a general rule, the method within the child has higher priority, right? It's going to be called first. If we have multiple functions of the same name within the parent and the child, right? Good? Does this make sense? Yeah? No. This is what I'm saying. It doesn't cause an error, but if you are calling something within the circle class, like say for example in our previous example c.toString, and we will see this right now, you are going to call the child one, right? Good. Is there any question? So we already discussed this. This is called method overriding. So now we have two different things: methods overloading and method overriding. Both are two different concepts of object-oriented programming, right? Method overloading, even with the same class, without inheritance, you can have multiple methods of the same name, but different set of parameters. This is overloading. Good? How you differentiate, how the compiler would differentiate between which one you want based on how many parameters you pass when you call this function. Good? Good. Method overriding is different because it has the same set of parameters and it's not within the same class. It's within multiple classes that have an inheritance relationship, a parent and a child. Both have the same function with the same name, same number of input parameters, everything is the same. Maybe the implementation is different, I mean the body itself. But then if you call it within the child, it is going to call the child one. If you call it within the parent, it's going to call the parent one. Good? So overriding is different than overloading. Great. So to test this out, let's extend our test circle class, the one that we had the main method in, and then write down these 4 lines of code. What we do, we already had the C thing. So what I want you to do is write these 3 lines. We're going to print line C.toString, and then define a new point class, and then also print its toString method. And let's see what is the difference. You have 1 minute for that, yeah. Well, yeah, this is the purpose of this code. I guess your question is there a point to call the parent toString method, right? Or within the circuit, is what you're saying? We will come into this as well. Yeah, there is a way to do this. One minute to write 3 lines of code. Is there anyone done? No one is done? Yeah. What is the output? You are done, but you didn't run it? And 7. Good. So what does it mean? That means, so let's first say what is the output. The output in this case is you are calling C.toString, which is this one, which is going to print x, y, and then radius equal, right? Then it's going to print 3.5, 65, and then radius equal 7. But in this one, it's going to call the point class, which we initialized using x65, y7. So the output would be 65, 7, right? That means if you call the child dot method, is going to call the child one, right? It's going to override the parent one and call only the child one. But that doesn't mean you cannot access the method within the parent. I mean, these 2 lines of code has nothing to do with inheritance at all. You have a child that's called point. It's a parent class, but you created an object out of this class, and then you called its method. So these 2 lines of code has nothing to do at all with inheritance. It doesn't even care about the circle class, right? Make sense? Is there any question? You guys are good? Okay. So we already discussed the super thing. And then here comes your friend question, which is a very good question. He said, can I assume that I am in the circle class right now, and I want to access the toString method of the parent? So what did we do? We did a method overriding by creating 2 methods, one at the parent, one at the child, with exactly the same name, same number of parameters. I told you this overrides the parent one, which means you only access the child one. Is there a way to access the parent one, right? Here comes the reserved word super again, and then you can do this by accessing super.method name. Well, tell the compiler I want to access this method that is in the parent, right? So to do this, something you can do is we are utilizing our toString from the parent. So we are modifying the toString method here in the circle class. Instead of saying center x and y, we are saying center equal super.toString, and then radius equal radius. So what do we do here? We are calling the toString method of the parent inside the toString method of the child, right? I see this like as neat, right? Because now you are getting something from the parent, you are using it, but you are extending it, right? Make sense? One example would be, instead of assume, this is just a very simple function, right? But assume you have a method in the parent that has 1,000 lines of code. And then you are a child of this parent. You want to have the same capability of this original parent method, but you want also to add something into it, like couple of lines of code. If you don't have access to this parent method using the super.method method of the parent, then you have to write the 1,000 line of codes plus the 2 lines of codes you want to write again, right? But now, by just calling this, you get the full capability of the method as the parent, and then you extend it yourself. Does this make sense? Do you guys have a question? Good. Okay. So we discussed this yesterday, but I guess it created some confusion, so let me revisit this, right? So I told you, if you have a child class, and then you create an object out of this child class, the first thing you do by calling the constructor is you call the constructor of the parent, right? And then we said, if you don't explicitly say this, then the compiler, please pay attention to this, because this is very important, right? And it's very confusing. We have multiple cases. The first case is you didn't write a code that calls a constructor of the parent yourself. Previously, we had super something something, right? This was calling the constructor of the point that has x and y as an input parameters. But now we don't have this. So the first case, if you don't call the constructor of the parent yourself within the constructor of the child, then the compiler will assume you are going to call the empty constructor. What is the empty constructor? The empty constructor is the constructor of any class by default if you didn't create one, right? But now if I call the empty constructor and then I go to the parent to call this empty constructor, I find no empty constructor. What's going to happen? You are going to have a compiler error. Why I have a compiler error here? Because you don't have an empty constructor and you didn't call a constructor with input parameters yourself in the child. How can I solve this problem? Any idea? Yeah? Yeah, or called super, exactly. So you kind of address one of these two things. You either create an empty constructor yourself in the parent or call the constructor yourself similar to what we did before. The last thing I told you in yesterday's lecture is it's a very good programming skill. And I told you if you look into any professional code, you find the first line of any class is an empty constructor. Why? Because it saves you a lot of issues. This is just one of them. There are multiple issues out of that, right? So make it like a programming practice for yourself. If you write a class, the first thing is just have an empty constructor. If you need other constructors, that's okay. We do constructor overloading, right? Good. Now we solve it using the second solution, which is call the constructor ourselves. By doing super 5, we are calling this constructor that takes one input parameter, pass 5 to x. So this is okay, right? Great. Another solution would be, here I don't have a constructor at all, but also I didn't call a constructor myself. So I didn't use one of the two things he just mentioned, right? And this gives you no error. The reason is, once you initialize a value, when you define it in on a class, the compiler does this initialization by defining a constructor itself, right? So you create a constructor. Here you kind of implicitly create a constructor to initialize x, right? And this is okay. Good. Here we solve this by using the first solution, which is creating an empty constructor for A2. A question that I had yesterday after the lecture, which is a very good question, is here, this constructor is assigning x to be 20, right? And then later, I'm assigning x to be 1. Which value should be the final value of x in this case? What do you think? Here I assign two different values, one at the parent, one at the child. What happens? Yeah, x at the end will be 1, because I just told you that the first line you do of the constructor of the child is to call the constructor of the parent, right? So this executes first. X is 20 here, so if you try to print x here, it's going to be 20. But afterwards, you execute this line, so you overwrite x, right? This is very important. Good. Okay. So this is kind of revisiting the concept of inheritance again in a different way. It's looking into it from a different angle. So what did it say? It says we have circle and we have point. If you create an object of circle, it's actually also an object of point, right? So you can refer to an object of the child. It's also an object of the parent itself. And this gives us some very interesting cases here, right? One possible case is if you define an object of a circle using like this circle C2 something, you can define an object of the parent to be point B2 and make it equal to the child, C2. What do we call this thing? We had a name for this thing. It has nothing to do with classes. We did this before in ints, doubles, floats. What do we call this thing? Yeah? Typecasting, right? So I told you before, if you have an int and you assign the int into a float or double, it's allowed without doing any casting yourself, because the compiler, now you are moving from the narrower type to the wider type. You can look into the child to be the narrower type. And then the parent is the wider type, right? So you can assign a child to a parent directly without even needing a casting, and then the compiler will do the casting for you. So this is allowed, right? Good? And then later you can say int a b2.getX and then c2.getX. That's allowed. What if you want to do this? This is not allowed. And this is the trick here, right? So let's look into this one by one. We created an object in memory that is called C2. We created another object. Actually, this word is not correct. We didn't create another object. We just declared another object of point B2, and we made it point to C2. So now we have a place in memory that is C2. And then I told you before that this line means you make B2 point to the same place in memory, right? But what is different than before is now B2 is still of a parent type. It's not a circle type, right? B2 is a parent type because you declared it to be point B2. Point class does not have a getRadius method, right? So we should know, like from our previous discussion, is a point does not have access to the methods of the child. B2 is an object of the parent, right? So it's an object of point which does not have access to the getRadius because getRadius is a method in the circle, right? So doing this is going to give you an error, right? Why? Because B2 doesn't have a method that's called getRadius. So both are pointing to the same thing, but they have different capabilities, right? Is that confusing? Okay. So what about this thing? This is allowed because C2 is of type circle, and then you can just say get circle. Good. So what about this one? So this is similar to the other. So this is similar to the other type, right? So remember when we had to cast from double to int, right? We said you have to do the casting yourself. So the first line here gives you a syntax error because C3 is a child, B3 is a parent. You cannot assign a parent to a child in the same mentality of you cannot assign a double to an int. What do we need to do to assign a double to an int? We need to cast it, right? So you need here to do a casting of type circle, and this is allowed, right? So again, moving from the wider to the narrower requires you to do the casting yourself. The compiler will not do it for you. Exactly the same thing. The best way to understand this thing is to know that a class is nothing other than a data type, similar to double and int, and a parent class is nothing other than a wider type, child class is nothing other than a narrower type, and then you apply the casting rules that we had before. Good? Okay, thank you so much.
planning something.